Over 100 billion aluminum cans are produced every year, supplying the world with soft drinks, energy drinks, and countless beverages. But behind every can lies an incredible journey of recycling, melting, rolling, shaping, and high-speed engineering. Today, we go inside one of the world's most advanced can-making facilities to see how recycled aluminum is transformed into millions of Coca-Cola cans, each one made in just a fraction of a second. The world now uses about 4 billion soft drink cans every week, but aluminum wasn't always so common. In the 1890s, it was a revolutionary and extremely expensive material. Aluminum cans didn't become popular for carbonated drinks until the 1960s. But today, they are used everywhere, with over 100 billion cans consumed each year in the United States alone. Around 45 billion of these cans are recycled. Over 90% of the recycled material becomes aluminum ingots used to manufacture new beverage cans. One of the world's largest recycling companies processes used cans shipped from around the globe to its plant in England. The cans arrive tightly compressed into bales weighing up to 1,000 kilograms, each containing as many as 65,000 used cans. Heavy-duty balers crush and compress loose cans into solid, uniform blocks. The machine then wraps the blocks with strong metal wires to keep them together. This makes them easier to stack, transport, and feed into the next stage. The compressed blocks are placed on a conveyor and carried into a 340 horsepower shredder. Aluminum cannot be separated with magnets like other metals, so shredded pieces pass through an optical sorting system at a speed of 3 meters per second. Infrared sensors identify which pieces are aluminum and which are contaminants. The shredded metal still contains paint, lacquer, and traces of other materials, so it must be cleaned before melting begins. 2 giant furnaces heat the aluminum pieces to a blistering 730 degrees Celsius, each handling up to 100 tons of metal. When the aluminum melts, it reacts with air and forms a layer of aluminum oxide on the surface. This unwanted material is called slag. Operators remove it using large steel paddles. Then a stream of molten aluminum flows into a massive holding furnace, roughly the size of a double-decker bus. The liquid metal must now be cast into ingots. Inside the casting mold, molten aluminum is added layer by layer. As each layer cools rapidly with water, it becomes dense and sinks, allowing more aluminum to be added on top. After about 2 hours, 3 enormous ingots are complete. Each one is nearly 10 meters long, weighs 27 tons, and contains the equivalent of 1.5 million recycled cans. Demand for aluminum is so high that these ingots don't stay in storage. They begin a 900-kilometer journey to a rolling mill, where they are reheated to 525 degrees Celsius. This loosens the atomic bonds and releases internal stress. The softened metal passes through a series of rollers that stretch and thin it out, like rolling pizza dough. With each pass, the metal becomes thinner until it reaches a thickness of about 0.25 millimeters and a length of 10,000 meters. These thin sheets are wound into giant coils and shipped to Coca-Cola can factories. One of Coca-Cola's main suppliers is a global producer of beverage containers. Inside the factory, high-speed lines can make up to 2,200 cans per minute. Each coil weighing 9,000 kilos will produce about 700,000 cans. The process is highly automated. First, the coils are unrolled into long sheets, then fed into a powerful drawing press. This machine stamps the aluminum more than 200 times per minute, creating the round discs that will form the can body. Each press stroke produces 14 discs, each about 14 centimeters in diameter. The leftover metal is collected, compacted, and sent back to the aluminum plant for recycling. A forklift moves the discs to the next machine, where the can body is formed. A metal rod pushes each disc through a series of smaller and smaller dies, stretching it into a cup-shaped container. The machine uses plenty of lubricant to prevent tearing. The lubricant also cools the aluminum, which heats up as it is stretched. As a result, the unfinished cans are oily when they exit the machine. A trimming machine then cuts and straightens the top edges. The cans travel upside down along a conveyor into a 6-stage washing system. The wash removes oil with detergents and sulfuric acid. They are then blasted with ionized air to remove the last traces of residue. After cleaning, each empty can weighs less than 15 grams, but must withstand 3 times the pressure of a car tire. Now, the cans are ready for printing. A rotating printer applies up to 5 colors with perfect precision. Coca-Cola's signature red is applied using a specific shade, chosen by the brand. Once printed, the cans travel to a machine that sprays a protective coating inside. This lining prevents the drink from tasting metallic and stops acidic sodas from corroding the aluminum. Next, the cans pass into a naking machine, which forms the narrow top section. Another unit shapes the upper rim where the pull tab lid will be attached. These steps happen at high speed, over 2,000 cans per minute. Any defective can is rejected instantly for recycling. The finished cans move quickly to the bottling plant. There, they enter the filling area. A high-pressure carbonator mixes gas with syrup so the drink doesn't foam excessively. The cans are cooled to 5 degrees Celsius to keep carbon dioxide from escaping. Filling valves can fill 130 cans at once, reaching speeds of 1,700 cans per minute. One operator monitors the machine to ensure it never runs out of lids. Inside the sealing machine, lids are crimped tightly onto the cans. To ensure accurate fill levels, a gamma-ray scanner checks each can. Any underfilled can is removed and recycled. At this point, the cans are cold enough to cause condensation inside cardboard boxes, so they are sprayed with water, warmed to 35 degrees Celsius. After 12 minutes, they reach about 27 degrees Celsius, safe for packaging. High-speed air jets dry the cans before they are grouped into 6-packs using plastic rings or packed into cardboard boxes of 12. A single aluminum can may be recycled and reused up to 8 times in 1 year. And here we are in a blueberry factory, where millions of fresh blueberries are processed every day before reaching stores around the world. First, they go through a careful cleaning process. Trays of berries are washed with strong flowing water, mist, and stirring paddles that remove dirt and debris without damaging the fruit. Then, powerful air currents dry them quickly while keeping their texture and flavor intact. Next, the blueberries travel along a conveyor belt, where small or clustered ones are separated. Advanced scanners with high-speed cameras and AI analyze each berry's color, size, and shape to remove unripe or damaged ones. After that, a final human inspection ensures only the best berries move forward. Finally, they're packed in containers, labeled for traceability, and prepared for shipment. Fresh, clean, and ready for consumers worldwide. This beverage factory in Munich produces more than 50,000 bottles every day. Before the drink is filled into bottles, it goes through several important processing steps, including a modern B-flash pasteurization system that ensures safety and quality. The filling area is designed in an arena shape and features advanced equipment. Once each bottle is labeled, it is carried upward by an ascending conveyor with a gentle 2% incline. Due to limited space, the dry end of the factory is arranged across multiple levels. In this section, A network of conveyors efficiently moves both empty and filled bottles, as well as crates, between different stages of production. Every step is carefully organized to make the process fast, clean, and efficient, helping the factory deliver high-quality beverages to customers around the world. Ready meals are a marvel of modern food manufacturing, offering convenience without compromising on taste. The process begins with the careful selection of high-quality ingredients sourced from trusted suppliers to ensure freshness and safety. Ingredients are then prepped, cooked, and assembled in state-of-the-art kitchens where precision and hygiene are paramount. Advanced machinery handles tasks such as chopping, mixing, and portioning, while trained workers oversee quality control at every stage. Meals are cooked using industrial ovens, steamers, or fryers to replicate home-style cooking. Once cooked, the meals are rapidly chilled or frozen to lock in flavor and nutrients. Packaging is another critical step designed to preserve the food's quality and provide easy reheating options. And here we have a chocolate bar's factory. The process of making Reese's peanut butter cups involves combining rich chocolate and creamy peanut butter to create the iconic treat. It begins with preparing the peanut butter filling. A mixture of roasted peanuts, sugar, salt, and stabilizers is blended into a creamy but slightly gritty consistency. In the production line, specially designed molds are filled with a layer of melted chocolate to create the cup's base and edges. The molds are then cooled to harden the chocolate, forming a sturdy foundation for the filling. Finally, the Reese's peanut butter cups are removed from the molds, wrapped in distinctive packaging, and subjected to quality checks. Afterward, they are boxed Over 100 billion packets of instant noodles are consumed worldwide each year. That's nearly 13 packets for every person on the planet, loved for their convenience, affordability, and delicious flavors. From mixing and shaping the dough to steaming, drying, and packaging, each step is carefully designed to deliver the perfect bowl of noodles every time. Let's dive into the incredible process that brings this beloved comfort food to your table. Instant noodles may seem simple, but their production is a fascinating blend of advanced machinery and skilled craftsmanship. In factories, a carefully orchestrated process turns basic ingredients into the quick and tasty meal enjoyed by millions. This convenient food, which goes from a dry block to a warm, comforting soup in minutes, was even named the greatest Japanese invention of the 20th century. And it's no surprise. Instant noodles have saved countless students and busy people from hunger when time is short. The story of instant noodles began with their inventor, who was inspired after seeing people waiting in long lines for a bowl of ramen in post-war Japan. His goal was to create an easy-to-make, nutritious, and affordable meal that could help fight hunger during difficult times. It all starts with wheat flour, the main ingredient. Large industrial mixers work tirelessly processing tons of flour daily. The flour is mixed with water and salt to create a strong and elastic dough kyun, which is essential for making noodles. This step is carefully controlled since the right moisture balance is crucial for the noodle's texture and shape. After kneading, the dough is left to rest, allowing the gluten to relax and making it easier to roll and cut. Once ready, the dough passes through a series of rollers that gradually flatten it, refining it until it becomes paper thin. This rolling process is key. It not only determines the noodle's thickness, but also enhances their elasticity by strengthening the gluten. Next, the thin sheet of dough reaches the cutting machines, where it is sliced into noodle strands. Although it may seem like a simple step, this marks a crucial moment in instant noodle production, shaping the final product that millions enjoy worldwide. At this stage, the length and width of the noodles are determined. Each cutter is equipped with adjustable blades that can create noodles of various shapes and sizes, from thin ramen strands to wider, flatter pasta-style noodles. Different blade configurations are used depending on the type of instant noodle being produced. Once cut, the noodles are collected on trays or conveyor belts. To prevent them from sticking together, they may be lightly coated with starch or talcum powder. At this point, the noodles are too moist and soft for storage, so they undergo a two-step cooking process. First, they are steamed at high temperatures to enhance their flavor and texture. Then, they are quickly fried to remove moisture and create a crispy texture that allows for long-term storage. This process stabilizes the noodle's structure and removes excess surface starch. The exact cooking temperature and duration vary by manufacturer and noodle type. After pre-cooking, the noodles are rinsed with cold water to stop further cooking and preserve their texture. They are then drained and undergo a drying process to remove any remaining moisture. Drying can be done through air drying or controlled hot air, with carefully monitored temperature and timing to ensure proper consistency. The final result is the familiar compact block of dry noodles, ready to spring back to life with just a little hot water. One fascinating part of the process is how the noodle blocks take shape after steaming and frying. The noodles are placed in molds that form them into the familiar square or circular shapes we recognize. But this is only half the journey. Every step is carefully engineered, like a well-rehearsed orchestra, to ensure that each packet of noodles delivers the same satisfying experience. So, what happens after the noodles are dried and ready for packaging? The secret lies in the toppings and seasonings that give each bowl its unique flavor and personality. While the noodle block remains largely the same across brands, the broth and seasonings set each variety apart. Instant noodle broths range from classic chicken to bold and spicy flavors. These broths are prepared separately in massive cauldrons, each capable of holding thousands of liters of soup. Spices, aromatic ingredients, and proteins are simmered together into a rich, concentrated liquid, which is then dehydrated into a flavorful powder. This dried seasoning not only enhances the taste, but also adds texture and color, making every bowl a sensory delight. Once the stocks and seasonings are ready, it's time for packaging. The noodle blocks, seasoning powder, and toppings are carefully packed into individual packets. This keeps all the components fresh and ensures they stay protected until they reach your kitchen. Finally, the packaged noodles are shipped to stores worldwide. In a large modern factory, millions of ice creams are made every day. This factory is filled with advanced machines that work quickly and efficiently. These machines mix fresh ingredients like milk, sugar, and fruit to create delicious ice cream. There are many different flavors, from classic chocolate and vanilla to unique ones like mango and caramel swirl. The machines pour the ice cream into cones, cups, and tubs before freezing them at very low temperatures. Some machines add chocolate coatings, sprinkles, or nuts to make the ice creams even more exciting. Workers in the factory monitor the machines to ensure everything runs smoothly. Quality checks are done to guarantee that each ice cream meets high standards. Once packed, the ice creams are sent to stores and supermarkets worldwide. Up next, we take a look inside a honey factory, where production is carefully managed to ensure purity and quality. The process starts when raw honey is delivered from beekeepers in large containers. First, it is filtered to remove wax, pollen, and other impurities. Then the honey is gently heated to make it easier to process without losing its natural benefits. Next, it moves through a system of pipes and tanks to ensure even consistency. Once ready, the honey is poured into bottles or jars using automated filling machines. Each container is sealed tightly to keep the honey fresh and prevent leaks. Before packaging, the bottles go through a quality check to ensure they meet industry standards. Labels are then added with important details like ingredients and expiration dates. Finally, the packaged honey is packed into boxes and stored in warehouses before being shipped to stores. This process ensures that pure, high-quality honey reaches consumers worldwide. There's nothing quite like a well-baked croissant with that crispy and soft in the middle, with the subtle flavors that melt in your mouth. However, croissant production must be done just right, especially when you're producing them on a high-speed line. The journey of a croissant begins with its ingredients. Factories use premium flour, rich butter, sugar, yeast, and a touch of salt to ensure consistent quality. The dough is mixed in large industrial mixers, where it transforms into a silky base, ready for the next crucial step. One of the defining features of croissants is their flaky and layered texture. This is achieved through a process called lamination. Large machines roll out the dough into thin sheets and layer it with chilled butter. The dough is folded and rolled multiple times, creating up to 27 layers of dough and butter. These layers are the secret behind the croissant's crisp exterior and airy interior. Once the laminated dough is ready, it's chilled to maintain the butter's integrity. The sheets are then cut into perfect triangles to create that iconic shape of croissants. Automated systems roll these triangles into crescents, a process that's both precise and mesmerizing to watch. Proofing is a critical step in the croissant-making process. The croissants rest in a controlled environment where the yeast activates, causing the dough to rise and develop its light and airy structure. Temperature and humidity are carefully monitored to ensure the croissants proof evenly, creating that perfect texture. Once proofed, the croissants are ready for baking. Industrial ovens bake them at precise temperatures to ensure even cooking. This is where the butter melts, creating steam that forms the iconic flaky layers. In just 20 to 25 minutes, the croissants emerge golden, crispy on the outside, and soft on the inside. Every croissant undergoes strict quality control to ensure consistency. Only the best croissants make it to the packaging line. The ones that don't meet the criteria are removed, ensuring only the best reach the customer. Modern packaging systems carefully wrap the croissants, sealing in their freshness. These systems can package hundreds of croissants per minute, ready to be shipped to bakeries and stores. As we continue, this factory process, one of the most popular treats in Asia, fish-shaped cakes. It all begins with batter being poured into fish-shaped molds on a hot machine. The molds close, and the cakes bake until golden brown. Some cakes are filled with sweet fillings like chocolate, custard, or red bean paste. After baking, the cakes move along a conveyor belt to cool down. Workers or machines check each cake to ensure it is well cooked and has the right shape. Cakes that pass the quality check go to the packaging area. In packaging, machines carefully wrap each cake in plastic or place them in boxes. Labels with the product name and ingredients are added. Finally, the packaged cakes are placed in cartons and sent to stores. And here we have a corn factory that makes corn pieces just like fried chicken. The process begins when fresh corn arrives at the plant. Each cob is carefully washed with clean water to remove dirt and prepare it for cooking. After that, the corn moves into large boiling tanks, where it is cooked until soft and ready for the next step. Once boiled, the cobs are cut into small pieces, making them easier to handle. These pieces then go through a coating stage, where they are covered with a crispy batter, almost the same way fried chicken is prepared. This special coating gives the corn a crunchy outside while keeping the inside soft and full of flavor. Finally, the coated corn pieces are packaged in plastic bags, sealed tightly, and made ready for delivery to stores and restaurants, where customers enjoy them as a unique snack. Over 7 billion marshmallows are eaten every year in the United States. That's almost 20 million every single day. Most of them come from large factories in Indiana, which produce around 40,000 tons a year. But how are these tens of thousands of tons of basic ingredients turned into billions of the soft white treats we know as marshmallows? Today, we're taking you behind the scenes to see how it all happens. Everything begins with the main ingredients: sugar, corn syrup, water, and gelatin. To meet daily demand, each plant receives trucks that unload up to 50,000 kilograms of sugar and 30,000 kilograms of corn syrup. Gelatin, which is the key ingredient for the fluffy texture, arrives as a dehydrated powder. About 5,000 kilograms of gelatin are delivered every day, enough to give structure to more than 2 billion marshmallows each year. Once these ingredients arrive at the factory, they go through cleaning and preparation. This first step is important for guaranteeing that every marshmallow produced is free of impurities. The sugar is sifted to remove any clumps or debris collected during shipping. The thickness of the corn syrup is tested to confirm it has the correct consistency, since even small changes can affect the elasticity of the finished product. Gelatin needs a special treatment. It is soaked in warm water to soften, turning it into a thick, clear liquid that blends easily with the other components. Proper soaking and dissolving are critical as they help create the marshmallow's light but chewy texture. After the ingredients pass quality checks and preparation, it's time for the main event, making the base mixture. This primary processing stage transforms simple ingredients into a fluffy candy. It begins with heating water in large industrial mixing vats to an exact temperature ideal for blending sugar and corn syrup. The sugar and syrup are added gradually, with constant stirring to create a smooth, even mixture. The blend is brought to a controlled boil, reaching just under 112 degrees Celsius, known in candy making as the soft ball stage. This temperature is perfect for achieving the right consistency, dissolving all sugar crystals without creating a gritty texture. As the sugar syrup simmers, the dissolved gelatin is added and blends smoothly into the hot mixture. This step thickens the syrup, giving it the sticky, stretchy quality that makes marshmallows special. But the real magic begins in the whipping stage. The mixture is moved to large industrial mixers that whip it rapidly, incorporating air and transforming it from a dense liquid into a fluffy foam. These machines are massive, capable of handling hundreds of liters at once, and are designed to work fast while slightly cooling the mixture as they whip. The whipping creates the light, airy texture that makes marshmallows soft and bouncy. During whipping, flavorings such as vanilla or other extracts are added, giving the foam a gentle, comforting taste. Natural colorings may also be included depending on the desired look of the batch. With the mixture whipped and flavored, it's time for secondary processing, where the texture is refined and the foam is shaped. The fluffy mixture is transferred to a depositor machine that portions it accurately. For classic marshmallows, the foam is extruded into long cylindrical ropes and then cut into even pieces. Advanced computer systems control the extrusion's speed and pressure, ensuring every piece is uniform. Some industrial depositors can produce thousands of pieces per minute, creating consistent shapes quickly and efficiently. For special shapes or themed varieties, the mixture is poured into custom molds. These molds come in many forms to match different uses and markets. After shaping, the marshmallows are moved to a drying area to firm up and keep their shape. Drying takes place in a carefully controlled room where temperature and humidity remain stable, as even slight changes could affect quality. The marshmallows are arranged on large trays, so air can circulate around them as they dry. Larger or denser marshmallows may need several hours to dry, while smaller or lighter ones dry faster. The goal is a texture that is soft yet firm enough to hold its form. After drying, the pieces are dusted to remove any extra starch used during molding to prevent sticking. Some are lightly coated in powdered sugar or cornstarch, adding a hint of sweetness and keeping them from clumping together during packaging. Packaging is an essential stage, making sure each marshmallow reaches the consumer fresh and safe. On the packaging line, pieces are sorted by size and type before passing through a metal detector that checks for any foreign particles. Once cleared, the marshmallows are portioned and sealed into airtight bags. Packaging machines are extremely efficient, able to process thousands of pieces per minute, with each bag filled and sealed precisely. To extend shelf life, many manufacturers use nitrogen flushing, a method where oxygen in the bag is replaced with nitrogen to prevent spoilage without preservatives. Larger marshmallow varieties may be packed in tubs or boxes for added protection or for bulk and premium products. After packaging, the marshmallows are moved to storage areas. Again, temperature and humidity are carefully monitored to prevent clumping, melting, or texture changes. In a soy milk production factory, the process starts when the beans are received and put into a machine. They are automatically moved and roasted. The roasted beans travel through pipes to be boiled. After boiling, the beans are mixed with other ingredients and stored through more pipes. The soy milk is then sent to the filling area, where machines automatically fill it into packs. Each pack is sealed, and the expiration date is printed. The packs move on a conveyor belt where straws are attached automatically and checked for issues. Then, the products are packed into boxes. Once the right number is reached, the box is sealed. Let's take a look at the Babybel factory that produces millions of small snack cheese balls. It all begins with milk sourced from dairy suppliers. The milk is pasteurized to eliminate harmful bacteria, ensuring safety and freshness. Next, a starter culture and rennet are added to the milk, initiating the cheese-making process by curdling the milk and separating it into curds and whey. The curds are then cut and drained to remove excess whey, forming the base of the cheese. These curds are pressed into molds, shaping them into Babybel's signature small, round wheels. Once molded, the cheese is aged in a controlled environment to develop its mild and creamy flavor. After aging, the cheese wheels are coated in a protective layer of red wax, which seals in freshness and prevents spoilage. Finally, the wax-covered cheeses are wrapped in the iconic Babybel packaging. The journey of making 7-Up begins with the main ingredients: carbonated water, high-fructose corn syrup, and natural lemon-lime flavors. These are carefully blended to create the base syrup. The mixture is then precisely carbonated, giving 7-Up its signature fizz. Next, the carbonated syrup is piped into a filling machine that dispenses the perfect amount of soda into each bottle or can. Every bottle and can is capped and sealed to lock in, the carbonation keeping the soda fresh and fizzy. Throughout the process, rigorous quality control tests ensure that every can meets 7-Up's high standards. Once checked, the bottles and cans are labeled and packed for distribution, ready to be shipped to stores worldwide. From factory to your fridge, that's how every can of 7-Up is made. Crisp, refreshing, and always ready to quench your thirst. Every day, millions of people enjoy banana chips globally, driven by the rising demand for convenient and healthy snacks. Bananas grown on expansive plantations covering thousands of hectares are skillfully transformed into the crispy, golden treats. But how are 5,000 kilograms of chips produced every day? A visit to one of the largest processing plants reveals the detailed process of making banana chips in factory. The bananas are harvested before they fully ripen, while their skins are still green and the pulp is firm. Harvesting is done using tools that carefully cut the bunches without damaging the plants, as bananas are a perennial crop. Once harvested, the bananas are placed in special containers to protect them from bumps or bruises. Workers carry the banana bunches on their shoulders to the transport area, where a system of hooks and ropes is used. The bunches are securely tied to the hooks and moved to the washing area. Here, workers carefully spray the bananas with fine water jets to remove dirt and germs. Banana processing plants are typically located near banana fields, since bananas are highly perishable and must be processed quickly to maintain their quality. To ensure freshness, bananas are transported directly from the fields to the factories using rope lines, refrigerated trucks, or covered cargo vehicles for short distances. Upon arrival at the factory, the bananas undergo strict quality control. After washing, the bananas pass through belts with forced air or soft drying rollers to remove excess moisture. This step is crucial because overly wet surfaces can affect cutting, frying, and the final product's stability. The banana peels are then removed using automatic peeling machines. For plantain chips, where the peel is thicker and firmer, manual peeling methods assisted by small cutting tools are often used. Once peeled, the bananas are transferred to high-speed automatic slicers for the next stage of processing. The slicing machines use circular blades to create thin and uniform slices, typically between 2 and 4 millimeters thick. The slices are then placed on trays or conveyor belts ready for heat treatment. After the antioxidant bath, the slices are gently drained. Most banana chips are made by frying. For this, the slices are submerged in hot vegetable oil, typically heated to temperatures between 170 degrees Celsius and 180 degrees Celsius. The slices are fried for a short time, typically 1 to 3 minutes, depending on their thickness and type of banana. The food-grade oil is filtered and renewed regularly to maintain its purity and flavor. During frying water inside, the slices evaporates, leaving them crispy. The temperature and time are carefully adjusted to achieve the perfect result: a golden chip with a crispy texture and no burnt taste. Temperature sensors and automated systems ensure consistency in the process. In some cases, alternative methods like hot air baking are used to produce a healthier option with lower fat content. For this, the slices are placed on trays inside convection ovens at temperatures between 110 degrees Celsius and 140 degrees Celsius for longer periods until they are evenly dried and toasted. After frying, the slices move along belts that drain excess oil. Gentle centrifuges or compressed air systems are often used to remove surface fat. This step reduces the caloric content, improves texture, and prevents oil stains on the final product. Removing excess oil also helps extend the product's shelf life by preventing rancid flavors and unwanted changes during storage. Once the slices are dried, they can be seasoned in various ways. The most common method is applying fine salt using automatic sprayers as the slices travel along conveyor belts. This ensures even seasoning for a balanced flavor. Weighing and dosing systems ensure that the amount of salt per product unit meets the required specifications. Some varieties feature additional flavors such as chili, garlic, onion, cinnamon, or natural sweeteners. After frying or baking and seasoning, the chips undergo gradual cooling. This is done in fresh air tunnels at controlled temperatures between 20 degrees Celsius and 25 degrees Celsius. Cooling helps the chips achieve their final rigidity and stabilizes their internal structure, ensuring they maintain their crispness over time. Once the banana chips pass quality control, they are packaged for distribution. Packaging is done using high-precision automatic machines. Depending on the target market, the chips may be packed in flexible bags made from laminated materials that protect them from light and humidity. Alternatively, they can be packaged in rigid containers with a nitrogen-modified atmosphere, which helps extend their shelf life. Mortadella production starts with carefully selected cuts of pork, traditionally the shoulder and back fat, which provide the meat with its signature flavor and texture. The pork is then ground into a fine paste using specialized grinders. This step ensures that the meat achieves the smooth, uniform consistency that Mortadella is known for. Next, A blend of spices and seasonings are added to the meat paste. The traditional recipe includes salt, black pepper, and aromatic herbs, giving mortadella its rich, savory taste. One of the defining features of mortadella is the addition of cubes of pork fat. These visible white spots add texture and help to keep the sausage moist during cooking. Once the ingredients are combined, the mixture is stuffed into large casings. These cylindrical molds give mortadella its traditional shape, and the air is removed to ensure the sausage is tightly packed. The stuffed sausages are then slowly cooked in steam ovens at controlled temperatures. This cooking process can take several hours, allowing the flavors to fully develop while the mortadella achieves its smooth, delicate texture. After cooking, the mortadella is cooled to set its shape and firm up the texture. Each batch undergoes strict quality control checks to ensure it meets the highest standards. Finally, the mortadella is sliced into thin, uniform slices and packaged, ready to be sent to stores and kitchens around the world.